In this video, we're continuing with the 5-3 slope idea. We're now into example 1. So the page before that I did on the video before, it was describing all about slope, and now we know how to use this formula. The one thing I changed in this formula here, so this is the same formula I introduced in the other video, is that I put these two letters here, which sometimes means that it's the slope between the two line segments A to B, like this. So it's saying I took the line segment AB, so A, that's supposed to be an A, sorry, A, and that's a B. So sometimes we name it as a subscript, and that's a subscript. You don't have to name it. So for instance, this one, I didn't give you the letters, so they're not named, so just do M equals. So I'm going to practice the formula with you. Leave a bit of space here, and we're going to go M equals, put the line. I want you to try to line it up like this, so it's equal. And we're going to go y2 minus y1 over x2 minus x1. And remember I said in the other video, subscript. Subscript. So subscript. If it's not subscript, you'll lose marks. It's not powers. It's under a little bit there. I forgot to name this. That's why I said leave some space. I want to name these points. It doesn't matter which order you name them, you'll get the same answer. So if you name this point 1 and this one point 2, but someone says, oh, I did 1 and 2 this way, that's okay, because you're going to still get the same answer algebraically. It'll still simplify to be the same. So if you want, you can go x1, y1, that's point 1, x2, y2, that's point 2. And we're going to put this in. So we're going to sub it in. y2 is 6. y2 is 6 minus y1, look, is here, 1. x2 is the 5, so 5. And then x1 is here, 2, minus 2. It's always minus. Then you're going to calculate it. So 6 minus 1 is 5. 5 minus 2 is 3. So this has a slope of a 5 over 3 rise, run, slope. 5 rise, run 3. If you're given a grid, we give you the option. If we don't give you the grid, so you can see the questions here, there's no option. You can't do it on the grid. So this one here, I'm going to show you one more time to prove to you what I just got. So if I plot the point 2 along the x, 1 along the y, and then 5 along the x. So 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, like this. So this is the point 1 and point 2. So if we did this, and I counted the rise and the run, so if I was, okay, I'm going to count the rise. Rise, how many squares do you get? 1, 2, 3, 4, 5. Oh, that's 5. And I count the run. And remember, we're making a 90-degree triangle. It's always along these two 90-degree lines. 1, 2, 3 squares along the bottom. Look at that. It's a 5 over 3. So that shows you that my rise is 5 and my run is 3, which is what I got. 5 over 3. Okay, so again, if we don't give you the grid, we want you just to do it with the formula. So let's practice the formula a few more times. So M, I'm going to label the points though. So I'm going to do, so see how, if this is point, it doesn't matter the order. If you flip them around, you'll still get the same answer. You'll just get, you'll have to reduce it. You might get 2 negatives. It'll still reduce the same. x1, y1, x2, y2. So I do that first, and then I name, after I name it, I write my equation. Again, try to line this up here on the equal sign. So we're going to go y2 minus y1, x2 minus x1. Okay, and we're going to sub in. We're going to go negative 2 minus 4. x2 is 3. Okay, so going a bit faster. Right, so remember, this is x1, right? That's x1, x2, that's y1, y2. That's how I'm listing it. x1 is here, so minus negative 5. So that would be negative 6 over 5 minus minus, or 3 minus minus 5 is 8. You don't leave it this way because we reviewed fractions before. So if you run out of room, just start a new column. Make sure you put equal. Oh, Also, you have to make sure you put equals down the sides. So for all these questions, I want M equals. You'll lose marks otherwise. And then continue your equals here, and we're going to reduce this. So what we taught you before in the fraction section is you always have to reduce. So you're going to divide the top and the bottom like that, and we're going to get -3/4, and that's fully reduced and beautiful. Okay, so you have to reduce. Yes, you do. So you have to reduce if you want full marks. So reduce, okay, that fraction. Okay. Sometimes you'll see me write ARF on a paper. A says always, R for reduce, F for your fractions. So always reduced fractions, ARF. It looks like I'm barking on your page. Arf, 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 arf. So hopefully you don't get a bunch of arf, arf, arf. So it's always, A for always, R for reduce, F for fractions. Let's try that again. So we're going to go, I'll label the points first. So this will be x1, y1, x2, y2. M equals, line up your line-up sign there, your equal sign. So again, I want the M equals, and then I want this, and I want equals all the way down. So this will be y2, y1, x2 minus x1. So pause and make sure you have the equals all the way down if you're doing this with me. Okay, and then we're going to fill this in. Equals, y2 is 4. So see how it's lined up? So this is, that's your y2, whoops, including the 0, 2, that's your 4, and that's your 5. So y2 is -4 minus y1 is 4. x2 is 2 minus -5. So this will get me -8 over 2 minus minus, so 7. Can I reduce that? No, I cannot. So then I can't reduce it, and you stop there. You can do it one more time for this question. x1, y1. I'm just showing you that sometimes you reduce, sometimes you don't reduce. It's not an always scenario. y2, so that's 0.1, 0.2. M equals y2 minus y1, x2 minus x1. Okay, and then we've got filling this in. So y2, again, can you double check? We're going to have equals all the way down here, and then M equals. So equals, and we're going to do y2, so it'll be, see how I lined up the equal sign? -4 minus y1 is 5, x2 is 3 minus -3. So -4 minus 5 is -9, and this is 3 minus minus, so 6. Can we reduce that? 9 and 6, yep, we can reduce them both by 3. So we're going to get -3 over 2, all done. Make sure there's equal signs all the way through. Okay, last example for this page. Find the slope of the line that passes through the points and visualize the graph. So we're going to try it again, and we're going to do the same thing, and then we're going to get a couple different special cases. So this is, again, x1, y1, x2, y2. I'm going to go a little bit faster. So M equals, and this will be line it up. So again, see how I'm putting the equals and lining it up right away? Right, and make sure, look, I'm putting M equals each and every time I do this formula. Oh, and you're writing the formula every time. You are writing this formula. So yes, you are. You're writing it every time you use it. You're not going to be using it as many times as me, so don't be sad about it. At least you don't have to write it a bazillion times. So I want the formula written every time, every single time. It's like your title. And then we're going to go -1 minus 4, 8 minus 5. When I get this one, I get -5 over 3, and I can't do anything else, so that's done. That one wasn't really a special case. Okay, that's not really a special case. There we go. But this one here, let's watch and see what happens. This is x1, y1, x2, y2. So we have M equals y2 minus y1, x2 minus x1, and we're going to sub in. y2 is 4 minus, 4. 4 minus 4. 2 minus negative 5. Look what happens on the top, though. In the numerator, you get 4 minus 4, so it's 0. And the denominator, I get 7. 0 divided by anything. So if I have 0 things, I'm dividing it by 7, everyone gets 0. So that is a 0 slope. And we know what that looks like. So when we visualize that, so that's what I was saying in the second part, is that can you see what's happening? So if I visualize this, I'm picturing negative 5 along the x, 4 along the y. This is 2 along the x and 4 along the y. It ends up being a horizontal line. That's why it's a horizontal slope, 0. So if you visualize those 2 points, they are beside each other. And that's why I said try to visualize the graph. Okay, the next one, let's try it again. x2, y2, and we're doing m equals, and it's y2 minus y1, x2 minus x1. Okay, y2 is negative 4 minus 5. x2 is 3 minus, 3. 3 minus 3, that gets me negative 9 over 0. Now this one here, I can't divide 0 into anything. So 0 in the denominator, so this, 0 in the denominator is going to get me undefined. My slope is undefined. When you picture the graph, when you picture this graph, picture it this way. You have the point. It's 3, 5, and 3, negative 4. They're right above each other. So that's why it's a vertical line. So it's an undefined slope. Isn't that cool? So the way that the formula works is that it will find the slope for you, and then over here, and remember, you're writing the equation every time with subscript, then filling it in. So we give you marks for writing it and then filling it in and then deciding what happens. So these are kind of our special cases because 0 is a 0 slope, which makes sense because the points are beside each other. Here, the points are on top of each other, so it's going to be an undefined slope. So the formula will show us the way.